Centripetal force is described as a center-seeking force. It was discovered by Sir Isaac Newton, who stated that centripetal force is a force that makes an object move or accelerate towards the center of a circle. And he stated that without centripetal force, the object would move in a line, which is a fact. Now the equation is the force of centripetal is equal to mass times velocity squared divided by the radius.
Alright, so this is our diagram of what the situation that we had with the rope swing. We measured the radius of the rope swing, which is 11.049 meters, and down here is what we're measuring. And in order to do that, we took a stick and pointed it directly at the bottom of there and found out that this angle right here that the stick made was 69 degrees, and from here we could find our change in height. You plug it in, you do the cosine and the sine, and you end up with Fy being 2.485 meters. Sorry, it's a little bit windy out here, it's a tad bit cold. Anyway, from here, you plug it into your velocity equation, which is the square root of 2 times g times the change in height, where Fy is your change in height. And you know that g is negative 9.8 newtons. You do all of that, and you get your calculation of your velocity to be 6.979 meters. And velocity in this circumstance is not correlated with mass whatsoever, so the velocity is going to remain a constant. You have your centripetal force equation up here, which is mass times velocity squared over the radius. So you have Fc, the centripetal force, equals mass times 6.979 meters per second squared, all of that, over 11.049. So to find the centripetal force, you just multiply mass times 4.408 to get your centripetal force. And from here we can find the force that the rope swing applies to the person as he swings across at this moment in time. We gotta do it like more of this way. That's where we got our angle from. You recording, Jacob? Alright, well this is Nick. And Nick is 180 pounds, which equals 81.81 kilograms. If he doesn't fall, we might be able to record his observation. Alright. Alright. That's Nick. Alright. And I am Patrick. And I'm 172 pounds, which equals 78.18 kilograms. Alright. Wait. Okay. Right. Frederick, stay. Stay, buddy. It's okay. This is Frederick. He is, what are we weighing at?
He is 8.7 pounds.
8.7 pounds?
3.95 kilograms.
3.95 kilograms. We have to put him in a bag or else he won't stay. Because, I don't know about you, but my typical cat doesn't like going off road.
Oh, he's out. He's gone, dude. He's not coming back. You're running, dude.
Hopefully it doesn't get too forgetful.
Oh.
Maybe we should get that. There we go. Frederick's in the bag. Got that rope? There you go. Frederick, I love you, babe. Frederick? You fucking stay? I'm scared that if I let go, he's gonna... Frederick, cat. Oh, baby, here. Sorry, baby. I'd like to thank Frederick for being such a good sport on this. He's a good kitty.
The force, you need to get the mass times velocity squared divided by radius. A first example of that would be to find Jacob's centripetal force, which he weighs 155 pounds, converting it to 70.45 kilograms, multiplying that to the gravitational force, which is negative 9.8, which is the force of the Earth, and adding that to the normal force, which is 1,000.96 newtons, we can get the gravitational force to be 310.55 newtons. Example of that will be to find Patrick's centripetal force on the swing trowel. His mass is 172 pounds, converting it to 78.18 kilograms, and multiplying to the gravitational force, which is negative 9.8, we get the force of the Earth to be negative 766.16. And adding that to the normal force, which is 1,110.79 newtons, we get the centripetal force to be 344.63 newtons.
Here is the graph that shows the data we collected when we were testing centripetal force. As you can see, the forces, both centripetal and normal, are both directly proportional to the mass. And the mass is on the x-axis and is displayed in kilograms, and the normal force and centripetal force is on the y-axis and is in newtons. Now the mass is the independent variable, while both forces are the dependent variable. Here is our mathematical model for finding the centripetal force. As you can see, the radius is 11.049 meters, which is the height of the rope swing. To find the velocity, we took the square root of 2 times gravity times the change in height, which is 2 times negative 9.8 meters per second times negative 2.455, which gives us 6.979 meters per second, which is the velocity, and you have to square that. So the force, or the centripetal force, is equal to mass, which changes throughout our experiment, times 6.979 meters per second squared divided by the radius 11.049 meters.